Hello, good morning dear students. Today we will discuss about a new chapter, that is heat and thermodynamics. Now about heat you all know, that is it is a kind of energy by absorbing which a body becomes hot and by rejecting which a body becomes cold. It means it is the reason of hotness and coldness of a body. Now mind it is only the reason, not the result, because the result is the temperature. So it is only the very initial and very fundamental concept of heat which we have learned so far. But it is not only enough, but it means a lot, okay, which we will see later in this video. Then there is a new term, thermodynamics. What is thermodynamics? If we break the entire word thermodynamics, we have two separate words, that is thermo and dynamics. Now the word thermo comes from the word thermal, which means nothing but heat energy. And dynamics is just opposite to static. By the word static we mean which is at rest, stationary, no zero velocity, means no velocity. So obviously dynamics means it which explains about the motion. It means it study about some motion or velocity, or we can say it deals with the velocity or the motion of something. But the motion of which? Motion of anybody? No. Here the motion or the velocity doesn't mean the motion of the entire body. Here the motion or the velocity means the motion and the velocity of the molecules of the material by which a body is composed. So we can say the motion or the velocity of the molecules due to thermal or heat energy is thermodynamics. Or based on this we can define thermodynamics like this, that is thermodynamics is the branch of physics which deals with the study of thermodynamics or study of the heat energy or thermal energy. Okay. So we can say that is a new term based on the word thermodynamics. Later we will see how we will get a new, modulated and a different explanation or interpretation of heat. Okay. So now we will just go back to the previous discussion, that is we all know that is heat is a kind of energy. But why heat is called energy? Because we all know that energy means the ability or capability to do work. It means if anything or something can perform any certain amount of work, then we can say yes, there is certain amount of energy is inside it. So similarly, by using or with the help of heat energy, we can perform so many works in our daily life. So many examples. For example, number one very easy example is cooking. Okay. Number two is by burning coal. The chemical energy is converted into heat energy, and using that heat energy we generally, by boiling water, we get steam, which is generally used to generate electricity in the thermal power station, isn't it? Or using the steam we can make steam engine run. So from this we can say that is using heat energy so many works can be done, isn't it? It means we can conversely say to do some amount of work some heat energy is required or some amount of heat is required. Now let's see the conversion, the opposite thing. It means can heat be produced by doing some work? Yes, obviously. There are also some of its example, that is if we rub our two hands, isn't it? Our hands get heated. It means some amount of heat energy is produced, isn't it? Now then if we take a glass tip, then if we stir a liquid, then after some time the liquids get heated, isn't it? Again, now when we insert the air inside the tire for our bicycle or any car, the tires get heated. Then what is the example? Then in these cases the opposite thing is happening. Opposite fact is phenomenon is happening. Previous cases we used heat energy. By using heat energy work was done, isn't it? By using heat energy what can be done? So many works. But here by doing work, by work done, by doing some work, heat is produced. So we can say heat, so that's why generally called heat and work are equivalent. It means in first cases we see that to do some work, some heat is required. In the second case we have seen to produce or to generate some heat, some work done is required. It means to do some work, some heat is required, and to produce some heat, some work done is required. So that's why in this sense work and heat and work are equivalent. Later Sir James Prescott Joule through his experiment showed that now if certain amount of work is done and if certain amount of heat is produced, then it has been seen experimentally, he proved that then he produced that the total amount of heat which was produced through the work done, the total amount of work done and total amount of heat is exactly equal. It means the amount of heat energy which was produced was exactly equal to the mechanical work through which the heat energy is produced, exactly equivalent. It means if 10 joule work, isn't it? If 10 joule work is spent, then 10 joule of heat can be obtained. It was experimentally proved by Sir James Prescott Joule. Equal amount of heat can be obtained by equal amount of work done, isn't it? Or by doing equal amount of work. By 10 joule of work, if we do 10 joule of work, then 10 joule of heat can be produced. Or if we use 10 joule of heat, 10 joule of work can be done. That's obviously very little amount of loss maybe. Okay. So in this sense, again we can get an alternate definition of thermodynamics. Previously we said it's the branch of physics which deals with the heat energy or thermal energy of a body. But here we can also say thermodynamics is also the branch of physics which deals with the interrelationship between heat and work. Can't we say? Obviously we can say. Then why heat and thermodynamics are jointly here discussed? As I said, later we will see how based on this aspect or the point of view or angle of thermodynamics, later we will get a new modulated and a different explanation and interpretation of heat energy. So far you have learned that heat is a kind of energy absorbing which a body becomes hot and rejecting cold. As I said, it is not only enough, it means a lot. Then heat is also called the internal energy. The internal energy of a body. Fine. Now if you just remember a few minutes earlier, I have told that the dynamics is the internal. It means it deals with the motion or the velocity of the molecules. Now where molecules reside? Since molecules reside inside the particle, inside every material, isn't it? It is not the entire body of the outside. Since molecules resides inside the material, so that's why it is also called the internal energy, since it is absorbed energy of the molecules. So since there is internal energy, so is there any term external energy? Obviously external energy, which we have already learned in class 10, which is called the total mechanical energy of the entire body, that is the bulk body. It is the outside, which is related to outside of the body. That is the potential energy and the kinetic energy. But it will be better to say external potential energy and external kinetic energy. So obviously there will be external, internal potential energy and internal kinetic energy. Yes. So what are the differences between the two? Okay. Very clear differences. Now during discussion of the potential energy, we know that when a body possesses energy due to change in its position, isn't it? If any body comes to at rest by changing its position, the entire body, then it is called the potential energy. Now it is only related to associated to the body. It means externally, not about the molecules. If we suppose a body is here, now if we take the body and if we shift it, displace it from here to there, again it comes to at rest. But due to change in its position, it is the external potential energy of the body which it has possessed due to change in its position. Again, or due to change in the shape or size, which is called elastic potential energy. Okay, due to change in shape and size, also there is some displacement. Okay, I already discussed. Okay, you can go through to my earlier videos. Okay, so one is the linear potential energy. It means if a body displaces along straight line horizontally, and if this shiftment takes place vertically, this is called gravitational potential energy. Clear? Now so this is the external potential energy which is associated to the external body, not associated to the molecules. Then kinetic energy, which is also called external kinetic energy. If the body possesses some motion, if we throw something, a piece of stone or a piece of iron, it is related to the motion of the entire body, the bulk motion. It is called the kinetic energy of the body, which is called the external kinetic energy or the internal kinetic energy. Internal means which is related to the molecules. So in class 10, which you have learned about the potential energy, kinetic energy, gravitational potential energy, all these were related to the bulk body, that's external body, not about the molecules. So this was the also mechanical energy. External potential energy and external kinetic energy total is called external mechanical energy, or we can say it's the bulk mechanical energy. Bulk means externally, okay. But here that is internal energy. Internal energy means about the molecule. So obviously, since in case of external mechanical energy we have seen the potential energy and kinetic energy, so obviously it is also applicable for molecules also. So obviously molecules will have its potential energy and obviously kinetic energy. So what is the potential energy? Now since inside every material the molecules suffers from experiences potential attraction, force of attraction or repulsion. Clear? So it is related to the internal potential energy. What is the definition of the basic potential energy? Forget about internal or external. Potential energy means the energy possessed by any particle due to change in its position. So when molecules suffer from when two molecules, suppose these are the two molecules, okay. So when the force of attraction, when they exert the force of attraction, so obviously they will come close together. Now since there is a change in their position, which means potential energy, and since it is happening, taking place internally, so it is called internal energy. And again, now if instead of attraction they experiences repulsive force, what will happen? Suppose they move in this direction. Initially they move in this direction and they come back. Again there is a shiftement, displacement. So that's why energy, because always there is a force, because work done is nothing, because energy is always measured by work done. And what is work done? Force into displacement. So force is always there. Previously was the force of attraction, displacement was also there. Now it's the force of repulsion. So F is always there, and again that is the cement displacement. So because of this work done, energy is stored inside it. So the force due to attraction, attractive force of attraction and repulsion among themselves, the molecules experiences some energy which is called internal potential energy. This is the potential energy. Then what about kinetic energies? It means it is depends on the thermal motion, isn't it? When they vibrate, so obviously when they will vibrate, they will possess some velocity, and this is called kinetic energy here. Since it is related to the molecules internally, so this is called internal kinetic energy. Clear? So internal potential energy, which arises due to force of attraction or repulsion, due to which change in potential is associated, internal potential energy. And then internal kinetic energy due to thermal agitation or vibration motion, this is called internal kinetic energy. Okay, so that is internal potential energy and the internal kinetic energy. Okay, the potential energy of the molecules, or instead of internal we can say the molecules. The potential energy of the molecules and the kinetic energy of the molecules total is called internal energy, which is called nothing. So this is the heat energy. So what is heat energy? Heat energy is the internal energy, means the total potential energy and total kinetic energy of the molecules, not the body. Clear? Which is called the total mechanical energy of the molecules. Whenever you will say about internal energy, means heat energy, it is related to only the energy of the molecules inside, not the bulk motion of the body. Bulk motion means external mechanical energy. Clear? So again we can define thermodynamics. It is which deals with the internal energy of the heat. Thermodynamics is the branch of physics which deals with the thermal energy or heat energy or internal energy or the interrelationship between heat and work. These are okay. So this is thermodynamics. Clear? Now one thing remember, that when we apply thermal heat energy, the internal energy of the molecules increases. So due to increase of this internal energy, their temperature increases. Now generally temperature is generally measured by average kinetic energy. Average kinetic energy is responsible. The kinetic energy of the molecules are purely responsible for change in temperature. If their internal kinetic energy, if their average kinetic energy increases, temperature increases. If it drops, drops up. Then again, why average kinetic energy? Not the entire, because we want to know that all the molecules doesn't get same amount of thermal energy. So they do not move with same velocity. So their kinetic energy is not the same. So we need to take the average. It is just like in a garden, in the garden of a boy. Okay, there are 5 coconut trees, and each tree is Okay, it contains in one coconut tree there is 5 coconut, in one is 4, then in 3, then in 2. Then we cannot take, okay, then we need to take an average value, isn't it? If each coconut tree contains equal amount of coconut, 5, 5, 5, then we can easily say in each tree contains 5 coconuts. But here it is not happening. In some coconut, in one coconut tree it contains 5. Or we can say mango tree or anything else. In 5, in first tree 5, then second tree 4, then 3. Then if anybody asks, then tell what is the total. Okay, then how many coconuts? Okay, how many coconuts does each tree contain? We cannot say. Then we need to take an average value. So since the molecules which are dust at the bottom, in case of a liquid or gas, if we hit it, so the molecules which are at the bottom, they generally agitated first, isn't it? Because since they are at the bottom, so they will get the heat energy at first, so they vibrate, so the kinetic energy increases, then they transfer the energy. So the kinetic energy or the velocity will not, of all the molecules will not be same. Some will get the bottom, they will get the thermal energy very fast initially, and those molecules which are at the above surface, they will take time, it will be delayed to reach that thermal energy top to them. So some molecules at the bottom will get the higher kinetic energy at first, then the latter the upper molecules. So the molecules which will be at the bottom, they will get the higher kinetic energy initially, then the latter. So some of the molecules will get higher kinetic energy, then the latter. Some molecules will have higher kinetic energy, some less. So then we will need an average or mean value. So this is the temperature. So that's why temperature is always measured by average kinetic energy. Okay. Now the fact is that the difference between the internal energy and the external. Now it depends. It better to say that it is the thermal agitation, because in case of liquid and gas, we all know that inside gas basically the motion of the molecules are random zigzag. Okay. So the temperature inside the gas, it depends on or you can say the heat of a gas depends on the thermal agitation of the molecules. Whereas in case of the solid, okay, its internal energy depends on the vibrational motion of the molecules, isn't it? Inside the gas, generally its internal energy depends on the thermal agitation. Since when we apply some heat, then you will get some thermal energy. Only in that case, its internal energy can be increases. Clear? But in case of solid, temperature increases depends on, or you can say the internal energy, total internal energy depends on its vibrational energy. How? Very easy example. Now, if a cylinder, if a cylinder which is filled with gas, if it is carried along with a van or any high-speed truck, its temperature will not increase. It will possess some velocity, but it will not increase its temperature. But if we hit it, only in that case its temperature will be increased. Then again, in case of a solid, if we take a piece of iron, then if we throw in the air, it will possess some motion, that is kinetic energy, but its temperature will not increase. Why? Because as molecules are not vibrating, it means that molecules will not grab any kinetic energy. It is just like now if we hit the piece of iron with a hammer, then it will become heated. Just see, now when it was thrown in the air, it was not heated. It only possesses some kinetic energy, which is the external kinetic energy, but it is not get heated. But if we take it and keep it at rest, then if we hit with a hammer, then it will get heated. Then it has no velocity, that is no bulk velocity, no bulk kinetic energy, but instead of that it became heated because of internal energy, because molecules started vibrating. In the initial case, though the body possesses some kinetic energy due to its velocity, but its molecules were at rest. But in the second case, the entire body was at rest, but due to heating, its molecules become suffering from its it is due to its vibrational motion. Then it's become agitated, and they started and they grab and this due to their vibrational motion, they possess some kinetic energy, and this kinetic energy is transformed into some amount of kinetic energy is transmitted into heat energy, which is the responsible for increasing its temperature. It is exactly like when we execute journey inside a fast moving train. Suppose the fastest bullet train. Now when we are inside a fast moving bullet train, now does our body get heated? No. But as soon as we get down from the train, then if we work for a while, then we get sweat. What is the reason? Example is the same. When the iron piece was in the air, it only produces energy, but inside molecules doesn't were at rest. They didn't suffer any kind of vibration, so the kinetic energy was zero due to its zero velocity. Now it is the bulk kinetic energy, as I said, the bulk kinetic energy, which is called the external kinetic energy. Since internal energy is related to molecules only. So since when we are inside a fast moving train, our body possesses velocity, whose velocity is equal to the velocity of the train. But the interior molecules, that is our limbs, that is the heart, lungs, kidneys, all are the molecules. If we assume this is the molecules of our body, they are at rest. So that's why our body doesn't get heated, we don't sweat. But when we get down from the train, when we started, the molecules, that is the kidneys, that is the heart or the lungs, all the limbs, the molecules start vibrating. They become agitated, they become kinetic, they possess kinetic energy. Then we become sweat. Okay. So this is the concept of the internal kinetic of the internal energy, which is nothing but it. So this is in this way, based on thermodynamics, then we can get a new modulated and a very different explanation and interpretation of it. Hope you have understood. See you in next video.